Okay, so 15.4 is graphing exponential functions. We're going to learn some new notations for this one, so some things you're going to need to pay attention to, but most of this is going to be done on the calculator. We just want to understand some different concepts and, again, some different notations. One of those different notations here is right here in terms of the variables they're using. So right here they're talking about using this for our exponential. So things to remember here in reference to what we learned before. What we learned before was this. Okay, so it's still the same thing, just in a different way again. So A here is our zero term, and B here is our R, or our common ratio, as we learned in geometric sequences. Okay, and things you want to remember about that are how those affect graphs itself. So in this particular case, we're going to look at this example where you have to match the graph with the given exponential. So things we want to talk about is just remembering, first of all, if our R is something that is a fraction less than 1, then that means it's going to make our function go down. Okay, so in this case that would be b, because our function is decreasing here. Okay, another one we can look easily at and know what it's going to be would be d. D is going down across the x-axis. In other words, it's a negative. Remember when we did transformations, if you multiply by a negative, it flips it over the x-axis. So that means this one would be d because it's multiplied by that negative. Now, A and C look very similar. They're both increasing. They're both going up, but it's the rate at which they're going up. So because number 1 is multiplied by 3, that's going to stretch it vertically. Now remember the rubber band. If we stretch something vertically, it gets skinnier. So that means that one is going to be A, because that one's skinnier than C. When you multiply by something that is a fraction, okay, it compresses it, which makes it wider, which means that one is C. So again, these basic concepts that we've learned before, but now we're just applying them to a different type of function. So the main gist of this lesson is graphing exponentials. Okay, so here it wants us to graph this one, and it has us identify our A. So A here is 2, B is also 2, so there's our A, and here's our B. And in graph. So what you can do here is just type this function in the calculator under y equals, go to your table, and I've selected 4 values, and I'm going to use the same 4 values all throughout this lesson. So I start with -2, -1, 0, 1, and 2. Now, the reason I do that is because it asks for the y-intercept, which is our 0 term. So I'm picking 2 points on either side of it. So for this particular problem, I get, now again, depends on how you type it in. If you type it in using alpha y equals or whatever, you may get a fraction or decimal. But here we get 1/2 or 0.5. Okay, remember, whatever helps you in terms of graphing. 1, 2, 4, and 8. So all we do is we plot those points, so -2 and 1/2. So it'd be like right here, -1 and 1. So about right there, because these are going by 1.5 on the y-axis. 0, 2, so 2 would be like right there, 1 and 4, and then 2 and 8. Now, all we do is we connect those points to make a curve. So there's our graph. Now, when we talk about end behavior, there are 2 end behaviors. As x approaches negative infinity, so what in the world does that mean? as you put your finger on the graph and you go to the left, as x is going to the left, because it's a negative direction, you're just putting what's happening to the graph. Well, right here it's flattening out, and it's flattening out on the x-axis. So the way we write that is as x approaches negative infinity, y is approaching 0, because on the x-axis here, the y value is 0. Then we do as x approaches positive infinity. So now we take and we trace the function going to the right. Well, here it's going straight up. Well, there, that means y is approaching positive infinity. Okay, and that's the infinity symbol, positive infinity, because it's going up to way, way, way up, like millions and billions. It just keeps going up. Okay, a couple other things to address here. Domain for exponentials is always all real numbers, unless it's a word problem. The range for this particular one is y is greater than 0. Okay, not equal to, because it never reaches the x-axis, but it's going from 0 up. 0 up. Okay, the next one, very similar, but you see they've changed the values here. So a is -3, b is +3. So remember that negative is going to make it go down. Flip it over the x-axis. We do our values again. So we put the function into the calculator. I'm going to use the same values. So I get -2, -1/3, -1, -1, 0, -3, 1, -9, 2, -27. So then I plot those points. So that one's really close there. -1, -1. So again, really not that far away. 0, -3, 1, -9, and then 2, -27. So here's our function. So again, remember that negative multiplying by negative is going to make it go down below the x-axis. And then we talk about our end behavior. Let's go ahead and do domain. Not that it asked, but domain again is all real numbers. Range, this one is y is less than 0. Okay, because it's here at the x-axis and going down, but again, it doesn't touch the x-axis. So for our end behavior, as x goes to negative infinity, so we trace the function going to the left, it goes to 0. Sorry about that, I don't know why it's not writing very well. I'll write it underneath it. Y is going towards 0. I'm not real sure why that lightened up there, but anyway. Okay, and then we got to go the other direction. So as x goes to positive infinity, so now we trace the function going to positive infinity. Now it's going to the right, it's going straight down. So now we say y is approaching negative infinity. Okay, so we have 2 more problems just like this. So hopefully we're kind of getting the idea. So let's go to this one. So this time a is 3. It's a positive, so it means it's going to be going up, except that b here, or our common ratio, is a fraction. So remember, we said if it's a fraction less than 1, it's going to make our function decrease. It's going to make it decrease. So then we do our values again. Again, I'm picking the same values because it keeps asking for the y-intercept. So I get -2, 12, -1, 6, 0, 3, 1 and 3/2, and 2 and 3/4. So again, because this is a fraction less than 1, look at your values, they have to be going down. So then we go and plot our points. Well, -2, 12 doesn't fit. That's okay. We'll go -1, 6, 0, 3, 1, 1.5, and then 2 is 3/4. So then this one is curving that way. Again, if you want to do domain here, domain is all real numbers, range. This is y is greater than 0. Now, even though the function's decreasing, our y is going from 0 up. Okay, now we do our end behavior. Okay, so let's say as x approaches negative infinity, so we trace the function going left, that's going straight up. So that means y is approaching positive infinity. Then we do as x approaches positive infinity, so now we trace the function going to the right, and that's going to 0. So one thing that you should notice here is that in terms of our behavior, we've got always one end is an infinite behavior, another one is 0. If we went back to the previous problem, remember it was negative infinity because it went down below the x-axis because it was multiplied by negative. But you just have to match those up. Alright, let's go to this problem here. So, same exact thing. A here is -2. B, 0.5. So it's a decreasing function, but the negative is going to flip it over the x-axis. So we'll see what happens here. So x, y1, still picking the same values. So -2, -8, -1, -4, 0, -2, 1, -1, 2, -1/2. So actually these values increase, but they increase because of the negative. So if you think about this, that's going to make them decrease, but when you flip it over the x-axis, it's actually going to reverse the behavior. So we plot these points, -2, -8, which doesn't actually fit. -1, -4 would be here. 0, -2, 1, -1, and then 2, -1/2. So then our curve goes like this. So it is actually increasing because it got flipped over the x-axis by being multiplied by negative. Domain for this one is, again, all reals, range. Y is less than 0 because it's going 0 down. Again, it's not equal to. Our end behaviors, as x approaches negative infinity, so as we trace the function going to the left, it's going down. So y is approaching negative infinity. So as x approaches positive infinity, so we trace the function going to the right, it's flattening out at 0. So something a little different in terms of graphing, but a lot of similar concepts that we've done in the past.